Okay guys, so welcome to this GOC II, the next session. Now this session basically is live on YouTube. It's going to be live on YouTube. So this session deals with resonance stabilization. So in GOC 1, what we studied was just few examples and how to decide the stability on the basis of resonance, hyperconjugation and inductive effect. And after the video, I got a lot of mails asking me to explain in detail about the resonance stabilization. I just gave a little bit idea how to understand the stability of resonance by means of certain rules, right? So here we are going to study the rules for resonance stabilization and few examples, and definitely there would be certain critical thinking MCQs which will be of the JEE, NEET and CET level. Okay, so now let's begin our session. Okay, so let's start first. Okay, what are the rules for resonance? I think this I have already discussed when I was discussing the GOC1. The molecule should be neutral. That is going to take the first preference. Then you have complete octet, right? And then you have more number of pi bonds. Then negative charge should be on electronegative atom, right? And positive charge should be on electropositive atom, right? So, and then if the charges are similar, they should be far apart because you already know that like charges repel. And if the charges are opposite, they should be as close as possible. So basically this rule deals with the charge separation. Okay, so let's try to see this. Neutral, complete octet, more number of pi bonds, negative charge on electronegative atom and positive charge on electropositive atom. Same charge far apart, opposite charge as close as possible. Okay, so just try to make the note of this particular rule, and so that we can actually solve the questions related to this. Okay. Now let's talk about this particular molecule. If you could see here, the question is asking which of the structure in among these two structure which is more stable. Okay, so let's try to apply the rule. The first is neutral. If you could see here, positive, positive, that means neutral, the category itself goes out. Then you have complete octet. You already know that a carbocation contains 6 electrons in total, right? So that means it is incomplete octet. So if you could see here, nitrogen with a positive charge, so it's going to be something like this. You have nitrogen, there is one hydrogen, one hydrogen. So if you could see here, 4 bonds in total, that makes the total of 8 electrons. Here again, it's 8 electron as well, right? So if you could see here, this is complete octet, as a result of which the second option, this is going to be more stable, right? So I hope this explains the second rule. So the first rule was neutral, and then you have complete octet, right? Now let's talk about this particular molecule. So if you could see here, this is nothing but an ether. You could say ether, methoxy ether connected to a carbocation, right? So if you could see here, the first rule is neutral. That means if you could see here, positively charged, so it's not neutral anyway, right? Both the structures are not neutral. Move on to the next particular rule. So you have neutral, it's not neutral anyway. Then let's talk about complete octet. We already know that carbon ions are in complete octet, whereas if you could see this particular oxygen, right, this oxygen with a positive charge is connected to 1, 2, 3 bonds. That means the total of 6 electrons plus 2 electrons from lone pair. So this is surrounded by 8 electrons in total, right? So this is basically complete octet. So if you could see here, this is going to be the correct answer. Second is going to be more stable than the first one. So in this particular structure, 2 is more stable than 1. Okay, now let's talk about this molecule, right? So if you could see here, there is a carbon ion. Now let's talk about carbon ion a little bit. So let's say you have this hydrogen over here, correct? And now, and this is connected to CHO, right? So that makes a total of 6 electrons. And then you have the lone pair with a negative charge. That means this contains 8 electrons in total, right? And if you could see here, this oxygen, definitely there are 2 lone pairs, and third lone pair basically gives this negative charge, right? So if you could see here again, the total comes to be 8. 1, 2, 3, 4, 5, 6, and bonded electrons make to 8. So again, this is complete octet. So both the molecules are not neutral, both have complete octet. If you could see here, the number of pi bonds are also same, right? So all these criteria has already been met. So what exactly are we supposed to do? we are supposed to talk about the electronegative atom, right? So here the electronegative atom is carbon, which carries a negative charge, and here the electronegative atom O carries a negative charge, right? But when you talk about electronegativity of oxygen is more, right? So electronegativity of oxygen is more, right? Is greater than electronegativity of carbon. So that means this electronegative atom should carry negative charge. That means second is more stable, right? So here we have the application of the charge principle basically, right? So this is, in this case, you have second structure is greater than, stability of second structure is greater than the first structure, right? Okay, now let's move on to the next question. Okay, so you have been given three structures. Okay, now it's interesting to note you are supposed to find out the order of stability of the following canonical structures or the resonance structures. Okay, now let's talk about this. So if you could see here, this is not neutral, not neutral, not neutral. So neutral is already out, right? Now you have complete octet. Let's talk about octet complete. Oxygen with negative charge obviously has two lone pair. This is complete octet. Carbon ions already have complete octet. Again, you have nitrogen with an extra lone pair and negative charge, it's complete octet. So all are complete octets. So you have more number of pi bonds. So this contains 2 pi bonds, this contains 2 pi bonds, this contains 2 pi bonds. So this criteria also goes off. Then you have electronegativity principle. Let's talk about this. Here oxygen carries a negative charge, right? Here carbon carries a negative charge, and here nitrogen carries a negative charge, right? So now these three conditions are already met. Now we are supposed to rely on the electronegativity principle, right? So what exactly is going to happen over here, right? So you already know that electronegativity of oxygen is greater than nitrogen, which is in turn greater than carbon, right? So obviously the stability will follow an order first. Okay, so this is going to be the first one, right? And then first, which will be followed by third, because nitrogen is there, and then this would be followed by second, right? So let me just write down, it's going to be 1 greater than 3, and this is in turn greater than 2, right? So this is basically the correct stability order. It's pretty much simple and easy to understand. Okay, so now let's move on to the next part. So yes, if you could see, this looks a little bit scary because this has seven structures. Now you're supposed to rank the order of stability. Now whenever such question comes, now you panic a lot. Now you have to understand one thing very clearly, that you are supposed to follow the rules of resonance in their order. Then it's going to be pretty much easy. So first is going to be neutral, then you have complete octet, then you have more number of pi bonds, then you have electronegativity, and then you have charge separation, right? So let's see, if you could see here, this is charge, this is your positive negative, then you have, again, basically if you could see here, every structure some or the other way becomes neutral. But if you could see here, there is no charge in this particular structure at all, right? So definitely the first place is going to be for compound number 1. Okay, now you have one, this is done, right? And then the next one is going to be, if you could see here, neutral, this is sorted out, right? Then you have complete octet. We already know that carbon ions, that is, sorry, carbocations, that is carbon with positive charge, they are incomplete octet, right? So they are basically incomplete octet. So try to get rid of this carbon ion. So this goes off, this goes off, again this goes, so if you could see here, carbon with positive charge, this goes off, this goes off, this goes off. There is only one structure in which there is no incomplete octet, that is 7. So 1 is greater than 7. Okay, now you have 1 and 7 together. Now let's talk about the remaining part. So if you could see here, structures 2, then you have 3, and then you have the sixth one. If you could see here, there is 1 pi bond, right? So there is 1 pi bond, and there is 1 pi bond, right? Correct. There is 1 pi bond, 1 pi bond, and then if you could see here, there is 1 pi bond. This is 0 pi bond, 0 pi bond. So definitely you are supposed to select between 2 and 3, right? And then 6, correct? 2, 3, and 6. So if you could see here, equal number of pi bonds. So this goes off, right? And then let's talk about the electronegativity. Again, if you could see here, the pattern is the same. Carbon is getting positive as well as negative, right? So this goes off. Now let's talk about charge separation. So if you could see here, positive and negative charge, unlike charges are far apart. That means fourth is going to be least stable than 2 and 3. When you talk about 2 and 3, so this negative charge is connected to the lone pair, so there is going to be repulsion, right? And this lone pair is going to stabilize the carbocation by donating electrons, right? So positive, negative, it's going to be attraction. So it's going to be 3 first, followed by 2, right? Followed by 2, correct? 3, then followed by 2, and then comes the sixth one. So this is 2, right? Then comes the sixth one, correct? Now, I think 1, 2, 3, 4, 5, yes. Then comes the sixth one. And now the remaining are 2, right? So fourth is remaining and fifth is remaining. So if you could see here, it's pretty much easy to understand. Positive, negative, negative, positive. That means, can you see the like charges coming together? If you could see here, positive, negative, 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 positive, negative, positive. Can you see there is more charge separation over here, right? So it's going to be there's going to be attraction here, attraction here, attraction here. It's going to be repulsion here, attraction here, attraction here. So basically more attraction is here. So it's going to be fifth one first, followed by the fourth one, right? Followed by the fourth one, correct? So if you could see here, 1, 7, 3, 2, 6, 5, 4. That's basically the correct order. Okay, so this is basically, this could be one of the hardest question, but actually it's pretty much easy to understand if you apply the rules of resonance correctly. Now, if you could see here, this is going to be your assignment question, and I want you to try this. And you have the email ID in the beginning of the slide. That's krishna922@gmail.com, and I'll be awaiting for the response regarding the order of stability of this series of resonating structure. Just apply the simple logic, the rules of resonance, and get the answer. Okay. I hope this session was pretty much useful to all of us, and this session might have actually simplified how to understand the stability of resonance structures. Okay, so if you like this video, please click the like button, and if you haven't subscribed so far, and if you would like to do so, then please subscribe the video. Okay, please subscribe the channels to get more periodic updates. Now, most important thing, our country is fighting with the coronavirus problem, so just make sure that you just restrict yourself inside, and then try to avoid going. In fact, do not move out of the house. Keep your personal hygiene as a preference, as well as make sure that you wash your hands frequently and take care of yourself. Take care, and all the best for all of you. Thank you.